Hey YouTube, Jeremy Wright here. Today's, let's see, Thursday. Oh gosh. Hey Google, what's today?
It's Thursday, April 4th, 2024.
That kind of day. So, howdy Aquapals, fish fanatics. What I'd like to share with you today is I'm looking back at, this is tank A, 55 gallon Central American tank. I've shared it many times in the past. But what I really wanted to talk about and share with you today is that I was under the impression that my pH meter, and I use these VivoSun, like pretty standard style pH meters, right? So I've used them for many years. I thought, I say I thought, I watched my 2-year-old daughter play with one. I was like, hey, no, don't give me that back. And then after I saw her playing with that about a month ago, I did a pH reading in this tank, and I got a reading that was so far off that I thought she had like recalibrated the pH, because this tank, which usually reads like oh 7.8 to 8.0 in pH, was reading like 10.5, and I'm like, well, that's not right. And I stuck it in another tank, and it read like 10.2, and I was like, well, that's not right. Okay, whatever. I'm just not going to get a good pH read for a while. So I actually ordered, it took me a few weeks to get around to it, but I ordered a new pH meter, and then it took me a week or so to get around to actually calibrating that. And when I sort of realized when I was doing the calibration process, I was like, uh-oh, this pH pen, the meter that I thought was reading wrong, isn't reading wrong. It's reading right. So I ended up coming back to this tank and just really, really looking at it kind of closely. Let's see if we can get a little higher view. So the tank wasn't reading incorrectly. I'm going to zoom a bit and just see what there is to be seen. Actually, let's look over here and see if we can view this a little bit. That's see the purling over here. It's kind of interesting. I'm gonna slide the whole show this way just a bit. So what I'm specifically looking at right now is the purling in the Anacharis. Like up in this area, they're just bubblesies all over the place. So anyway, that is what it is, right? So not actually what I'm trying to show you. Back to the pH thing. So I was operating on false impressions, thinking that this tank is significantly lower in pH than it was. So once I got the other pH meter in, the identical one, and I went through the process of calibrating both of them, and I recalibrated the old one, and oh, wait a second, this wasn't even off in the first place. And I recognized that like immediately. I realized that I'd made a mistake, and my assumption was that the pH meter was wrong, when actually, in fact, it was reading exactly correctly. I just didn't believe it. So, how can a super healthy appearing tank that doesn't have anything otherwise indicating that it's got any troubles at all, plants are growing great, what happened? So I think I've sort of deduced that it was probably just the level of food that I was adding into this tank. So there are a lot of guppies in here, and I wasn't doing actual water changes. I was topping it off, but even yesterday I tested the TDS and the pH of my tap water, and actually I'll just get that out. Give me just a second to pull that. I don't have to guess. I can actually read you the results. So my tap water as of yesterday had 28 parts per million TDS, total dissolved solids, and 7.18 pH. So almost neutral, very soft, low contaminants. Little Rock, Arkansas is where I am, and our water is historically like crystal clear. You can drink it right out of the tap unfiltered. It's fine. It does have fluoride in it, which I think is kind of harmful for consumption. It can harm your pineal gland. It can actually cause crystals to form in your pineal gland. So, you know, do your own research on that. Don't listen to me. But there are reasons that I would drink filtered water over unfiltered tap water, even if you're in a place like Little Rock that has super low total dissolved solids at a level of 28 parts per million. Take it from me, that's very low. That's lower than you'll find in like most rainwater. So, looking at this, how did the pH climb? Well, there's really only one way that things go into water. And when we're talking about pH, generally pH goes up as total dissolved solids go up, or as alkalinity, things that can oppose acids or things that can neutralize acids are generally thought of as alkalinity or alkaline agents. And that's not necessarily the same as a base or a Lewis base, although you can kind of consider them the same. They're not really the same. So, but alkaline agents are things that can neutralize acids. We'll just consider it that for definition purposes for an aquarium. And so how do you get things in the water that can neutralize acids or neutralize positively charged protons, free-floating protons in the water? So that basically means we've got things that are either negatively charged or things that can accept a proton. And that's a lot of stuff. So generally, almost anything that you add into water, almost anything, right, is either going to be a salt or something that's capable of binding to a proton. And that's sort of the short of that. So salts are basically things that are ionically bonded, like a positive and a negative atom. Excuse me, sorry, I was coughing. I was trying not to, and I had to let it out. So salts are like sodium and chloride binding. And anything that ends in an IUM in chemistry is going to be positively charged, like a +1 positive charge. Anything that ends in IDE is going to generally be a -1 minus charge. And so those IUM and IDE things come together like potassium and chloride or sulfide, magnesium, and something that ends in IDE. Those things come together to make salts. And generally metals are going to be one side of that, and non-metals are going to be the other side of that, if you were to look to a periodic table. And going back to how does the pH creep up? Well, what do we really add into aquariums? Some people add fertilizer, okay. Almost everybody adds fish food. So if your pH is creeping up, back off on the level that you're feeding, or do water changes. And generally, I'm not a fan of water changes. So there is one other thing that you can do, and that's actually what I chose. Rather than doing big water changes, I actually want all of that stuff in the water here. Now I say all of that stuff. Let me look back to my test results from yesterday. Tank A, this tank that we're looking at, temperature was 75.5 degrees Fahrenheit. Total dissolved solids, 85 parts per million. The pH went from 9.8 down to 9.51, down to about 9.01. So I'm actually going to get a read on this and show you what I'm going to do about this. So let's aim a little higher with the tripod, maybe something like that. That's not quite enough. Guess I'm gonna have to loosen this thing, find out if it will aim higher. No, it won't. So we're gonna be just all together coming loose and free with that. So fine. What I'm doing now is busting out the pH meter. And too much light over there, so we'll come over here. Can you read that? Like super high. So we're back over 10. 10.45. Like, whoa, that's high. I'm going to give it a swish. Generally, this drives the reading down. So if it's going to read lower than that, I'll be able to swish it around a little bit, drive the reading down, and then stop swishing it, and it should climb. And then stabilize. That's sort of a way to get a quicker oh wait, is it going to be going down? It is going to go down some more, so I can swish it some more, find out what these don't read accurately instantaneously. You sort of have to give it a moment and wait on the reading to appear. And that's just a thing from pH pens. There's not really a way around that. You got to wait on it to read correctly. So it actually is in the 10.3 range. Okay, so from here, what I'm going to do is add some acid. Because I don't really want to do a water change. I want the nutrients that are in the water. I don't want to remove them. But this is just a pH down solution. Now I can swirl the tank a bit. So I'm actually going to come in by hand. Give it a little bit of a mix. Now, the top of the water has not yet churned with the bottom of the water. But I'm going to see how much that affected the read. We're already down to a 9.8 something. 10.08, huh. It's pretty high. So I didn't affect it very much. So obviously there's a lot of alkalinity in this tank. And, I think I'm going to do a water change instead of just try to modify it with, so I didn't think it was going to read that high today. I thought we were going to get a reading something like 9.5, 9.1. And then I was going to back up and just add some acid. But clearly I had a flawed understanding of what was happening in this aquarium. And so I'm going to go back and read the general hardness and the carbonate hardness off. General hardness is only 150. Carbonate hardness is only 40. So I'm going to do another test, and these are fun SWTM 16-in-1 drinking water test, but it's got 16 panels of data in one thing, and I don't use these very often, so it's going to take 15 to 30 seconds, so we'll just count that off and I'll get a reading, and I'll share with you exactly what we find. So, hey Google, set an alarm for 20 seconds.
You got it. Your alarm's set for 4:44 p.m.
So this is going to give me a reading on total hardness, free chlorine, iron. That's going to be nice. I'll write down the iron level. Copper, lead, nitrate, and nitrite. Those are always useful. Okay, Google, stop. So, let's see. Iron level, I'm going to say that's 50. Oh, that's total hardness, sorry. It's about 50 ppm total hardness. Iron is 0, so I could probably benefit from giving this one some chelated iron. Copper's at pretty much 0, lead's at 0, nitrate. You know, I can read nitrate, actually. I'm going to say it's about 5 ppm. Nitrite's at 0. Sodium chloride's at 0. Total chlorine, 0. Fluoride seems to be 0. Cyanuric acid is at 0. Ammonia chloride, 0. Hydrogen sulfide's at 0. Total alkalinity shows to be at 0. No, not right. pH shows to be pretty low. No, not right. So for some reason, we've got something that's operating as a buffer, a major buffer. Did I get a total hardness read? Yeah, 50. This is a little bit mysterious. A little bit mysterious indeed. Total hardness. I'm gonna write that down. Alkalinity was at 0. That's not right. The alkalinity. Now, what a test panel like this is trying to do is infer something and then guess as to what this is. So sometimes tests like liquid tests or test strips are actually wrong. And I think we just found one of those examples, because unless we actually have an excess of hydronium ions, which are OH minus, if that's the case, it would take a lot of acid to offset it. That might be what's going on. But I'm shocked enough by what's at play. I think I'm still going to do a water change. I think I'm going to do like a 50% water change on this tank, which just isn't how I normally play this game. Like the big planted aquarium, stable systems. Yeah, I usually just don't do that. So let's back up and get a look at the tank again. I think you can just glance in here and see this is a fairly healthy system now. Generally, there's not a lot of light that gets down to the lower reaches of this tank, and you can watch some of my other videos, but every few weeks I have to come through and just clear out a bunch of guppy grass and Elidea densa and really work to get enough light to penetrate to the lower areas of this tank. So the grasses and the little bacopas and kabambas and the phoenix moss and the other grasses will actually have a chance, because this stuff just up in the top reaches, it grows so densely that it just chokes out the light. And there's a bunch of light in this tank. So we can see now there are 2 4-foot LED shop lights that each have 2 tubes each. There's also a 3-foot plant grow light and a 2-foot fluorescent, like a T8 maybe. And so this tank has a lot of light, and it gets choked out. Some of my friends, LRB Aquatics, say that a lot of people run too much light. Well, sometimes you gotta run a lot of light. Sometimes you don't. So I've got tanks that have a lot less light than this. I mean, even the tank next to it, it's just got a Hygger. Like, that's it. Just one Hygger, and I'd honestly rather it have more light, but it's got red root floater up top that really block out a lot of the light. And then next to that, it has an Aponogeton Ulvasia, and those tend to grow up and then across the tank. So they, in addition to the floaters, that you can see, this one's growing like all the way to the front. It's blocking some light, so I'll probably come through and clear the top of that tank. But this one over here, no float. A little bit, just a little bit of floats, but not a lot. It's a pretty much clear tank. So what we do about this? Well, we got a lot of light. Cool. We'll keep running a lot of light. But also, plants tend to absorb nutrients better when the pH is lower, especially through their roots. And there are quite a few root plants, but I haven't done a pH test in the soil, in the substrate. All I've done is get a pH read of the water. Now those two are going to have some correlation, but they're not going to necessarily match identically. But all the same, the pH is too high in here. And I think I still know why. It's because I feed this tank like heavily. And between the food and the animal wastes. I think that's what's driving up the pH, but I haven't exactly determined what that was. So you're kind of with me as I'm struggling through understanding this. And that's why I'm recording this, is a lot of people try to hide their mistakes. I'm trying to show you my mistakes. And maybe it's just that I'm very, very comfortable in my hobby level right now. But when something weird happens, that's what I want to share. Like, I can show a whole bunch of stuff that's just going fine, like all over the place. Right now, I want to show you the weird stuff. This is the weird stuff. And so one possibility is that in the past, when I wasn't checking my tap water or watching it closely, the pH was significantly higher, and I was just doing top-offs rather than draining water and then refilling it. And what happens when you do top-offs? Through evaporation, evaporative loss, we don't lose the dissolved solids. We only lose the water around the dissolved solids. So over time, the aqueous solution, which is the water in the tank, becomes more and more concentrated, sort of like the Great Salt Lakes or the Dead Sea. The stuff over time becomes more briny, more high pH, more alkaline, more high in TDS. But there were also a lot of plants growing in here, so they were soaking up some of that and making it seem like, if I pull out a pound of plant matter every 3 to 5 weeks, or maybe a pound and a half if I go 5 weeks, where did all that plant matter come from? Like those Legos came from the water. Like they were floating around, and then we built plants out of the Lego blocks that were in the water, the nutrients that allow us, that are the building blocks. And all that had to come from somewhere. Well, that comes from fish food. And so on the one hand, I can look and say, well, the nitrate level is almost zero. Like I could read it. It's not zero, but it's almost zero. Nitrite level is zero. Ammonia level is zero. So the plants are literally using that stuff up. And clearly there's a pretty heavy plant matter to animal matter biomass difference. And you want that. You want that to be like way heavy in favor of plant mass. So you don't end up with a situation where ammonia, nitrate, and nitrite are being allowed to build up. Now there's an example of another tank, a 5-gallon tank I have in another room, another guppy tank, where I recently took a large, or a large-ish, what do you call them? Chinese evergreen. I can't remember the Latin name. Chinese evergreen, though. It's what I would call an old lady plant, just a common house plant. And you would probably recognize it if I showed. Actually, I'll pause it. I'll go over there. Okay, so this tank here, the little 5-gallon, like right up there, had this Chinese evergreen growing from it. And I grow them in quite a number of different places. They soak up nitrates pretty quickly, pretty effectively. It definitely wasn't ready to like show. This is just it's a workspace. But there's a Chinese evergreen here growing from that tank. When I removed that large amount of plant mass, this tank didn't have enough plant mass to offset the animal biomass, and I began accruing a little bit of nitrate and nitrite. So I need to really add more plants to this tank because there are a bunch of guppies. This is actually an important guppy tank to me. And that's what I was going to say about that. So your plant and animal biomass ratios need to be heavily in favor of plants. And now back out here looking at tank A again. Clearly there's a heavy bias towards plants in the biomass ratio, plants to animals, and that's how it should be. That's why there are no nitrites, no ammonia, and just a little bitty bit of nitrate in here. And That's how it should be. But perhaps I'm going to do a water change. And I normally just don't believe in doing that unless there's a problem. Like maybe there's a bunch of nitrite in a tank, like 10 ppm of nitrite, and you're like, what? Where did this come from? Or it's a new tank and things just aren't balanced yet. But in a tank that's been running for years like this, I generally don't do water changes, and I just do water tests and then generally believe my results. But I got in this situation where for a month or more I wasn't believing the pH, which leads us back to the situation. How did we get here? I was taking pH readings and I didn't believe them. I thought my meter was wrong. So I got lazy about it and then ordered another one and then didn't use it immediately. And then when I got around to checking and calibrating things, I found, oh, my pH meter was just fine and dandy. And, that's just my fault. So, yeah, sometimes the guy operating the equipment needs to know what he's doing and actually believe the equipment. And I didn't. So I'm going to go back. Given that pH is a logarithmic scale, I'm going to have to remove quite a bit of water to bring this back down to where I think it should be. So if I do like a 50% water change and it's at 10 point something right now, actually I added some acid. Let's see where it came down to. It's showing 9 point. Now it's over 10 again. 10.12, 10.17. Yeah, that's way too high. Like, I'm shocked I'm not seeing more something. I mean, I'm looking in this tank and I'm seeing plants purling, which shows me that there's plenty of CO2. I'm just kind of shocked. Things are growing well. 10.32 pH. Like, darn. I feel like a goofball for allowing that to happen. But, again, that's why I'm showing you my flaws rather than pretending like they don't happen. And I think that's probably very common among YouTubers and people in the hobby who are in media, social media. They're not going to show you when they mess up. I want to show you when I mess up and tell you about it and talk about it and see what happens and how it got there. So, anyway, I think probably going to cut it here and then actually do that water change that I keep daring myself to do. But for the most part, I don't have to do water changes like this. And this is a rarity. This is an oddball situation around my place. And actually, we'll just go down the list. I'll read what my other tanks were. 7.84, 7.93, 8.4, 8.34, 6.29, 7.91, 7.35, 6.88. It's like a 7.50 that got scratched out because I did a water change, a 6.46 that got scratched out because I did a water change, a 7.70 scratched out because I did a water change, a 7.47, a 7.27, and a 7.18. Like, okay, those are regular old normal believable pH levels. So this one, yeah, just an anomaly, and for the moment I'm just going to have to leave it as a mystery and think that a buildup of hydronium ions might actually be the case, because as the alkalinity test shows, this tank is almost nil on alkalinity. I don't believe that. But again, I didn't believe the 10.5 pH reading. So if I was going to say one of them's wrong, the pH is right, the alkalinity's wrong. Also, pH lines on test strips are often incorrect. They're trying to actually read alkalinity, and that's why you'll see a low pH on a test strip when, if you were to put a pH meter in the tank, you would actually read something that's not the same as a test strip or a color liquid test indicator solution might be. And then we have to ask, well, what is the pH meter actually doing? Is it reading pH? No, it's reading electrical conductivity. And hey, watch this. Hey Google, how does a pH meter work?
According to Wikipedia, the pH meter measures the difference in electrical potential between a pH electrode and a reference electrode, and so the pH meter is sometimes referred to as a potentiometric pH meter. The difference in electrical potential relates to the acidity or pH of the solution.
Did you get that? So it could actually be that in this situation, the pH meter is not giving an accurate reading. All the same, I want to try to normalize the situation. And to do so, I think the best thing that I can do in this situation where I'm a little bit confused about what's going on as far as the water chemistry, the best thing I can do is actually just do a water change. So, thanks for sticking with me. If you like this sort of thing and this sort of talk and chat, give me a like or subscribe. Drop some comments. I'd love to chat with you, and I'll let you know in the comments section what happens with the water test and the water change. Adios.